So we're talking about conic sections here. In geometry, you've done cross sections before where you had various three-dimensional objects and you've crossed them with a plane and they resulted in different cross sections. We're just using the cone. In fact, we're using two cones, so they call it a double napped cone, where the vertices are touching right there. So if we take a cross section, we'll take a plane and slice it through at different angles, and the outline results in these four shapes here. And these are the conic sections, because we took a cross section of a cone. And we've got our circle, ellipse, parabola, and hyperbola. And those are the shapes we'll be studying in these next few sections here. So there's all the introductory statements. Down here at the bottom you see the general form, which we don't use very often. We're going to be using the standard form on the next page here in just a moment. But the idea is that if you have a general form, it's good for certain things, but it's not good for other things like finding the vertex or the center, or identifying the radius of a circle. So it has pros and cons. So if we start in this form, we will have to turn it into the standard form we need, and to do that, we need to complete the square. So we're going to start by reviewing completing the square in general, and then in one of our examples, we'll be completing the square with the circle itself. All right, so let me turn over to the next page. So here at the top, we're going to review completing the square. This is not a circle. We're just using an old example that we've seen in the past. Then we'll get to the circles themselves. We've done circles before back in October, and some of this will be review. But example 2 down there will be completing the square, and that's a new twist on the work with circles from what we've seen before. All right, so here's this is actually a parabola, right? So here we have 2x squared plus 8x plus 4. What we're going to do is just review how to complete the square and turn it into an h and a k version of this. What I call h and k, the book calls standard form. So we have to make sure the leading coefficient is 1, and if it's not, we divide everything, both left side and right side, by that value. So x squared plus 4x plus 2. All right, so what we did was we divided by a, the leading coefficient. Next, we're going to move the constant term to the other side. Watch your sign change there. For the next step, what we want to do is we want to find that magic number. We want to add a value that is found by taking b, dividing it by 2, and squaring the result. And we have to add that to both sides of the equation. So I'm just setting up the equation again from the line before. So that value of b, we don't use the original b, we use the new updated b. There it is. 4 divided by 2 is 2. Square the results. It happens to be 4, so we're adding 4 to both sides. Now, on the left, you have a trinomial, and we call it a perfect square trinomial, and so we can factor that. So that becomes x plus 2 times x plus 2, so we'll write that as a binomial squared, x plus 2 quantity squared. So that's completing the square. And there's our h. If we brought this back over to be a negative 2, that would be the k as well. So we could find the vertex of the parabola if we needed to. But those are the main steps. And we'll see similar steps with our circles. Occasionally there might be slightly different, sort of minor differences between this and working with the circle and the ellipse and hyperbola, but we'll get to that when we get to that. Here is our circle. You remember that at the center we use the h and the k. There it is in very tiny print. And the point on the circle itself, on the rim of the circle, we use the x comma y. So those are the 4 values that we have. And then the 5th is the radius. There it is. There's your standard form of the equation of a circle. Notice it looks like x minus h, but that's not a negative h, it's a positive h. In other words, you always change the signs when you take that center and plug it into the equation, or if you take the equation and pull the center out of the equation, you always change the signs. Of course, the radius is positive. Now, if your center is at the origin, then your h and k are 0, so it would look like this. All right, so here's example 1. We've done this kind of work before. The point 1, 4 is on the circle, so that'll be the x and y coordinates. It's on a circle whose center is at -2, -3. That's the h and the k. So they do give us the center. We have the h and the k, but we don't have the radius, so that's what we need to find first. We could use the distance formula because we have endpoints of a segment, and it's not too far from the distance formula to actually use the standard form of the circle anyway. That's a variation on the distance formula. So let's just go with that. Let's plug in our 4 values here, x minus h. So we have an x of 1, h of -2. So 1 minus the -2 quantity squared plus, now y minus k, 4 minus the -3 quantity squared, and that will equal the radius squared. Again, we're trying to find the radius anyway. So 3 squared plus 7 squared. And that's 9 and 49. All right. And so if we were to take the square root of both sides, we would have root 58 for the length of the radius. There it is, root 58. But now we have what we need for building the standard form of the equation of a circle. So we want x minus the center, -2, so that'll be x plus 2, quantity squared, y plus 3, quantity squared, and that equals the radius squared, and the radius squared is 58. So that's the equation we want. Again, notice that it looks like the signs change between the -2 and the +2, the -3 and the +3. That's kind of the pattern we're observing here. What if we don't have standard form, right? We're trying to sketch this circle, which means we need the center, but I can't find my h and k because we don't have it set up in that notation, right? So we need to find the radius, we need to find the center, and to do that, we have to complete the square for the circle. All right, so step number 1, make sure your leading coefficient is 1. Now you have to look at both the x squared and the y squared because we're looking at both sets of variables now, and they are 1. If that was not 1, you would divide everything by that number. Next step, we're going to move the constant term to the other side, but at the same time as we do that, we're going to bundle up the x terms. Give yourself some space. Bundle up the y terms. That's a positive on the y squared. Give yourself some space. There's the constant term on the other side. So as we move the constant term to the right, you want to create a space like this so that you can create a trinomial. That's where we're headed. All right, so we move the constant term to the right-hand side. Next, we want to add this b over 2 quantity squared to both sides. So we have to look for both the x's and the y's. So on the x's, that's your b, the -6. So over 2 is -3. You square that. What we're doing is we're adding 9 to both sides. But then you also have to do that for the y's. And on the y's, its value b is -2. So divided by 2, it's -1, square that. +1, so we're adding 1 to both sides. Now you have two trinomials that they can both factor. So this will turn into x minus 3 quantity squared. There's your plus sign in the middle. Y minus 1 quantity squared equals 4. So now we can identify the h and the k, and there's the radius squared. So my center is located at +3, +1, and the radius is 2. So as I graph this with a scale of 1s, there's my center. We want to find that radius of 2 and plot points above and below the center that are 2 units away, to the right and to the left of the center that are 2 units away, and those will give us the 4 outer points that will just give us some landmarks here to create something that looks fairly round. All right, here's the last example. Let's find the x and y intercepts of this graph. Again, we found x and y intercepts before in past chapters, but not on a circle. So here we go. Let's start off by finding x. Now, if we want to find the x-intercept, what that means for us is we want to keep the x variable and get rid of the y, meaning plug 0 in place of y. So x minus 4 quantity squared plus 0 minus 2 quantity squared equals 16. And now you can see we just have the variable of x that we're working on. and we'll work to isolate that variable. When you take the square root of both sides, don't forget you need a plus or minus. Don't forget that plus or minus. And then we want to simplify the radical when possible, right? So you can factor that 12 into 4 times 3, looking for perfect squares. So that'll be plus or minus 2 root 3. So x is 4 plus or minus 2 root 3. Now we solve for x, but we want to leave it in the ordered pair to indicate we have an intercept. So as an ordered pair, 4 plus or minus 2 root 3, comma 0. Those are my two x-intercepts. And we'll finish off with finding the y-intercept. Right, if you want to find the y-intercept, you have to keep the y variable. That's what you're solving for. Get rid of the x. That means we're going to plug a 0 in place of x. You can see we have the same 16 on both sides, so as you combine the constant terms, they will drop out. So y minus 2 quantity squared equals 0. We take the square root of both sides, and it's still 0. So we get y equals 2. Again, leave that as an ordered pair, so the answer is 0, 2. That means we have one y-intercept and two x-intercepts.